Right, hello. I wasn't originally intending this, but it's just that I've been working through a couple of TYS papers myself, for math and also for other subjects. And I realized while I was doing this particular question, by the way, in case you can't see, this is question 11 of 2018 paper 1 in the A level 10-year series. And I realized that the thing about APGP problems involving things like finance and savings and all that is that they confuse a lot of students, including myself. Because normally for APGP application problems, it's quite straightforward. You are very much able to see where it is that the AP is supposed to be brought in, where it is that the GP is supposed to be brought in, and then you can apply the formula. But in this particular case, or rather in both the questions that I'm going to show you today, the problem with savings problems, right, is that a lot of times they will say people got deposit something at the start of each month or at the start of each year. And then at the end of each month or at the end of each year, got some bonus, some interest. So we need to account for both the amount at the start of each month or year and the amount at the end of each month or year. That's the very difficult part that a lot of people, including myself, find to be tricky. Because these two, right, are two completely different GPs, two different geometric progressions. So, as I said, sometimes there can be AP problems lah in finance, application problems. But normally, when we are dealing with things like that, we are dealing with geometric progressions, GPs. So can I just revise a bit with you the things that we know about geometric progressions? So if I have a geometric progression, right, the nth term un is just a r n minus 1, where a is the first term, u1, and r is the common difference. Now, for the sum of the first n terms, there are two possible formulae, right? One is the following. And the other one is, instead of r minus 1, I flip it. It's now 1 minus r. And why is this the case? Because, right, think about it. If, okay, I have a fraction here, right? What is something that I have to take note of every time I write a fraction? This thing cannot be 0. Okay? And obviously, we are looking at the sum of the first n terms. The sum has to be positive intuitively, right? Or rather, it should be positive. But basically, this thing, this formula over here, is for cases where the modulus, okay, where the magnitude of r is greater than 1, such that r minus 1 or mod r minus 1 is greater than 0. Okay, this one is for mod r less than 1, such that 1 minus r or 1 minus mod r, make sure that your denominator can never ever be 0. Okay, so basically, if mod r is less than 1, then it also follows that you have a sum to infinity. Okay, if you have a sum to infinity, then it is a over 1 minus r. This only is the case, once again, if mod r is less than 1. So in this case, we would say that such a series is convergent, which is to say, if I have a series u1, u2, u3, no, actually u1 plus u2 plus u3 plus etc., all the way to infinity, the sum to infinity is some kind of real number. So if it's convergent, right, this is also to say that the limit of this as n goes to infinity is some kind of real number that can be defined. If it was divergent, then it would diverge to some kind of infinity, and then we cannot define it as a real number. Okay? So just a recap on the formulae for geometric progressions that we need to be familiar with. Let us go now into the questions. Okay. Let's see. Mr. Wong is considering investing money in a savings plan. One plan P. So this entire part is about P. P allows him to invest 100 bucks into the account on the first day of every month. At the end of each month, the total in the account is increased by A%. So if A equals to 0.2, right? This means that I increase by 0.2%. What is 0.2%? By 0.002, correct? So this means that how much is the 100 worth at the end of 31st of December 2026? Okay, initially I start with 100. Okay, and then this 100 increases by 0.2%. So this is 100 times 1.002. Okay, can? And then I apply this increase in 1.002 how many times? From January 2016 to December 2016. That's 12 months, right? So I apply this increase 12 times. So therefore, this is going to be 102.43. You run off to the nearest cents, okay? Not to the nearest 3SF, to the nearest cents for all finance problems. Okay? Okay, next, this is the one where I'm going to show you the table method, okay? So you're probably familiar with this, but I just want to take you through slowly and recap. Because I sorry to say this lah, but I find that sometimes the way that Hwa Chong teachers explain this table method may not be very clear sometimes. So it says Mr. Wong invests 100 on the first day of each of the 12 months. So let us look at the nth month, January 2016. How much did he have on the first day of January 2016? He put in 100, right? Then at the last day of January 2016, on 31st of January 2016, he got this $100, and then total in the account increased by 0.2%, so 1.002. That's on the first and the last day of January. Then for February, okay, I have this entire thing. Okay, 100, 1.002. Okay, and then I plus 100 because it's the start of a new money. He will go to the bank and plus this extra 100 inside. Can? So because he plus this 100 inside, this means that I am going to get a amount of this on the first day of February 2016. And then on the last day of Feb 2016, what is happening? I have this entire thing, right? So I have 100, 1.002 plus 100. And then on the last day, 28 or 2016 was a leap year, right? Okay, fine. 29 of February 2016. The bank sticks this thing in the brackets here and will times this by 1.002. I mean, 0.2% monthly interest is kind of realistic lah, sad to say. But anyway, you can probably see the pattern, but let's just do a third row just to convince ourselves, okay? So at the first day, I have this entire thing. I am not going to simplify yet. I want you to see the pattern. Then only we can simplify in terms of n. Okay, so I have this entire thing. 100, 1.002 plus 100. This entire thing times 1.002. And then Mr. Wong goes into the bank. Then he adds this extra 100. This is he do one. Anything in blue is he add on the first day one. Then anything in pink is the bank add on the last day. So the bank on the last day of March 2016, 31st of March 2016, it's just going to have this entire thing, and then it will multiply this thing in orange by 1.002. I'm not going to write it out because I don't have space, but you can probably see the pattern. So the question wants, find the total amount at the end of 31st of December. So December 2016 means I want what? The 12th month, right? N equals to 12. So I need to sub in somewhere n equals to 12. Okay, let's try. So from here, we can generalize that you see, right? If I can factorize my 100 out, right? So they want at the end. Let's make the amount. So it's the one in pink, right? Yeah, it's the one in pink. Okay, so last day, let it be Sn. I can take the 100 out. And do you see that this is just a geometric progression? Because I have, what is my initial? The initial amount that the bank added in, right, is just 1.002. And then I'm looking at this formula here, people. Yeah, this formula here. So my U1, which in this case, I'm looking at the amount that the bank multiplied it by, is 1.002. Then my common difference also happens to be 1.002. Power 12 minus 1. And then on the bottom here, R minus 1. don't need to simplify. You can just key this monstrosity into your GC and it will give you a very nice answer. Once again, round to the nearest cent. If I round it to the nearest cent, we'll get the very nice answer of 1215.7. I'm not showing you the GC pressing here because frankly, if I need to teach you how to press your GC, you probably shouldn't be watching this video. And secondly, because my OneNote is currently lagging, so I will pause the recording for a bit while I fix this technical issue. Okay, sorry about that. Technical issue has been fixed. Now let's go to part C. This is the part where I wanted to show you how to press your GC for something, okay? So, part C says Mr. Wong continues to do this. So everything that he has been doing in part A, part B, he still is doing. Okay? Then it says they want you to find the month in which the total will first exceed 3,000. So do you notice, people? I already have amount on first day in one column in blue, amount on last day in one column in pink. Now, I'm using dark mode, so I use blue and pink instead of blue and red lah. Sorry, red somehow doesn't show up very nicely on this background, as you can see. So if I go into my GC, and you see that I've keyed in already. So at the start of each month, right? At the start of each month, I can express this list in blue here, Y1. So you notice that by observation, right? At the start of each month, can you see my cursor? I'm not sure if you can see my cursor or not, but I'm trying to point lah. So basically, you know what? I'm going to, can I make the GC? Okay, ignore this Y2. Follow my cursor. I'm pointing at the terms in Y1. Okay, so I can take the 100 out because that's the initial amount that he invested. And then at the start of each month, I have R power, in this case, I key in X instead of N lah, minus 1 over R minus 1. Because he will add another 100 at the start of every day, but then the common difference from one month to the other month is still 1.002. Because any difference, right, is not going to come from how much he put in. Because a GP, right, a GP, how do you get from one term of a GP to another? It's by multiplication. Who is doing the multiplication here, the bank or Mr. Wong? It's the bank, right? That's why we don't take the common difference to be the 100 that he put in because that one is addition. We take the common difference to be the 1.002. That's the multiplication that the bank does. Okay? I hope that's clear on why we're using 1.002. And then this one, Y2 in red slash pink, is the one that we have explored over here in pink already. That's the one that we use to solve part B. So for part C, I'm going to use GC table. So I'm going to open up the table. And remember, when you are using GC table, right, can I emphasize, because there's more than one column here, right, you need to copy out the table, at least 3 rows of the table. So the row that you're interested in, you must copy out. The row on top of that row, you must copy out. The row below that row, you must also copy out. So obviously, you can't use multiple colors in an exam, but I'm going to do it for teaching purposes now. I only need 3 rows, so don't need to draw so thick. Actually, why I go and draw so long? Sorry. Just a small one will do. Okay, so I have N, then I have the amount on first day, and the amount on the last day. So you saw me key into the GC table already. And GC table, you will see I want it to exceed 3,000, right? So I go here. The first instance in which either of them exceeds 3,000 is N equals to 30. Okay, so I copy out these 3 rows, the 29, the 30, and the 31. So I'm going to copy it out now. That one was what? 2983.7, is it? Oh, 2982.7, 2988.6. Yeah, you can skip over this bit if you wish it to. It's just me copying. 3194.8. Okay. So I want either of these to exceed 2000 because let's look at the question now. What did the question say? The question say explain whether this occurs in the first or last day of the month. So they are open to either the blue list exceeding 3000 first or the pink list exceeding 3000 first. They want you to tell them which one is it that exceeds 3000 first. So the row I'm interested in is this one, n equals to 30, and then hello. Okay, yeah, n equals to 30. So from here, you can see equals to 30, right? What is 30 months after first what is 30 months after January 2016? You can do your mental math lah. It's gonna be June of 2 years later, June 2018. And you can see that because this one exceeds first before this one, I can write that this first happens, the first incidence is on the first day. Or you can just write occurs on 1st June 2018. Okay? Is that all for part one? Yeah, that's all for part one. Wow, this question is damn long. Okay, next. Alternative plan Q allows him to invest $100 on the first day, yada 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 yada. Okay, each 100 incurs a fixed bonus of B. So this is a fixed bonus, right? So there is, how do I explain this? This is not really an arithmetic progression. I don't believe it's correct to think of it as an arithmetic progression. In fact, this isn't even APGP at all. It's just basic algebra. But here we go. Last part will involve some actual serious H2 math. So let's see. Find in terms of B how much $100 invested in 1st January 2016 will be. Okay, so this is alternative plan Q. So anything that I've written on the right of the paper is about plan P. Anything that I'm writing below the paper is plan Q. Okay. For this one, right? The value at the end of 31st of December 2016 is very simple. You can just write it in one step. I have how much 100 invested. Okay, so he invests 100 on the first day of every month, right? So after 12 months, what is the total amount that he invests? He puts in 100 every month for 12 months. So the total amount that he put in himself is 1200, correct? And then what is the total amount that the bank put in for him? For each $100, the bank will put in B. And there are 12 sets of $100. So the total amount that the bank will put in is 12B. Done. Okay, next. Mr. Wong invests 100 on the first day of 24 months. 24 months. Okay, so in this case, N equals to 24. So total value, I'm going to write it out in full for you, okay? Because actually, I did this paper actually just yesterday. I don't know why I'm being confused, but I just saw this question yesterday. But basically, this is the way that I presented it when I first attempted this paper myself lah. I know it's not the most optimal, but it is the way that I did it and it's the way that I got the correct answer. So, do you see, right? If n equals to 24, at the start of the first month, he puts in 100, and then the bank will add in B. Then he put in another 100. Then what will the bank add in now? B or 2B, right? Because there's 100 here, there's 100 here. So the bank will add in 2B. And then after this third month, he add in another 100. Then the bank will add in 3B and etc, etc, etc. All the way until 100, and then bank will add in 24B. So this will be 400 plus B plus 2B plus etc 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 plus 24B. This one, right? How I did it was I did it as follows, okay? 1 plus 2 plus etc etc plus all the way to 24. Please don't go and be stupid and evaluate this thing manually, okay? You can just key into your GC as, do you see that this is just a sum? You can just key this thing into your GC. It's here. math 0, I'm just going to use x 1 to 24. And it will give you 300. So the sum of all integers from 1 to 24 is 300. Wow, amazing discovery. So that is 2400 plus 24b. That's the answer for this one. Yeah, I say it's not optimal because this is worth 1 mark. I don't think that everything I wrote here was worth 1 mark. But it got the answer, so I'm not complaining. Okay? Please don't complain either. What gets you the answer will get you the answer. Okay, part 3. They said find the value of B for plan Q, right? Such that both plans give the same total value in the account at the end of the 60th month. So total value for Q at the end of the 60th month is 6,000. I hope you understand where the 6,000 is coming from. And then I want B. How many B's? I want 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus da, 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 plus 59 plus 60 B. So how much is that? Don't be stupid. Use your GC. 1 all the way to 60. 1830. Okay. Plus 1830B. You understand what I'm saying, right? Yeah, I know it's late at night, but I hope I'm still making sense late at night. Anyway, so that's the total value for Q, right? And then for the total value for P, let us go back to what we looked at earlier. They now tell us A equals to 1. So total value for P, right? Is it still what we found out earlier? No, right? Because now the value of the common ratio R has changed. So instead of 1.002, it's now 1.01 because it's 1%. Okay? And then raised to the power 60 because it's how many months I'm interested in. 1.01 minus 1. This thing is equals to 6,000 plus 1830B. Then don't be stupid, just go into your GC. I'm not going to show you how to press your GC for this because I trust that you can be trusted to key this into your GC, right? So if you key this into your GC, you will get B equals to 1.23. Done. Okay? Can? Okay, let's take a short break, or rather I will take a short break, and then after that we can go on to looking at this very, very similar question. Alright, hi. So for this question, it's very, very similar. Let us apply the lessons that we learned earlier. Okay, so I'm not going to do a commentary for this one, mainly because I'm tired and there's still one more thing I want to record tonight. So I'm just going to do, and let's see if you can follow, okay? I will still talk about some things. So how much... Okay, wait, pause here, read the question, try it out if you have to pause here for a bit. Okay, Ken? Let us go. So I meant to say let's go. I'm so sorry. Okay. So interest is added into the account at the end of each year. Fixed rate of 5% is at the beginning of each year. Oh my goodness, I'm so tired. Okay. Fixed rate of 5%, right? 5%. So how much will there be in the account at the end of 1 year? It's just however much he put in times increase by 5%. So that's just times 1.05 lor. Yeah, I think that's it. 1 mark. Show that at the end of n years. Okay. Yeah. I confess I'm not doing this live, okay? I actually attempted this about half an hour ago at 7 something PM before starting the recording. So let us go. Let's go. Oh my days. I don't know what's wrong with me anymore. So at the start of the first year, he had X. At the end of the first year, he had 1.05X. At the start of the second year, he has this entire thing. And then he goes, yay, I earned some interest. Let us put some more money. This is the part that he put. This is the money that he put in plus X. And then the bank say, okay, I have this entire thing. I will multiply this entire thing by 1.05. Let us repeat this process for the third row. And then he says, okay, I will add another X. And then the bank will take this entire thing. And then, multiplied by 1.05. I can also write this as 1.05 squared 1.05x. Let me tidy that up a bit. Plus x plus 1.05x. So if I want to expand this further, I can see that in general, I have 1.05 n minus 1. So I'm looking at both this thing and this thing. And I generalize it from here to be in terms of n. This is 1.05 power n minus 2 x. So if I expand this, I can attempt to expand this 1.05 n minus 1 times 1.05. So that's just 1.05 n x plus 1.05 n minus 1 x plus 1.05 n minus 2 x. Now that's a lot more elegant. So what is this? This is a geometric progression. So once again, what is the common thing here among all these three terms that I can factorize out? Is 1.05x, right? And then I apply my GP formula. My common ratio is obviously 1.05 n minus 1 over 1.05 minus 1. So this is the standard GP formula. I hope you're seeing it. We can try to simplify this. So I think the tricky part here is how the hell do you get 21? This is how, okay? Bottom is still this. If I expand, I get I can factorize the 1.05 out. So this will just be 1.05 power nx minus x. And then 1.05 minus 1 is just 0.05. This is where you get the 21 from. They want to show that it's 1.05 power n minus 1. Yeah. Then I can factorize the n out. What? So that I can factorize the x out. So that is x. Yeah, that's it, right? That's it. We have done it quite easily done. Yeah. Of course, we know that QED doesn't actually stand for quite easily done, but let's just pretend it does. After how many complete years will he have? For the first time, at least 12x. Okay. This one, you can use your GC. You can use your GC to solve just like you use your GC to solve here. But we don't have to, because this is actually quite a simple expression in my opinion. We can actually solve algebraically. So, they want us to find what again? It's greater than 12x, is it? Yeah, okay, so 21. This thing, okay, this thing is greater than 12x. Greater than or no, at least 12x, right? The question asks at least 12x, so it's greater than or equals to 12x. Yeah. This thing can cancel. 12 over 21. 12 over 21 is just 4 over 7, so this will be 4 over 7 plus 1 is 11 over 7. Now, remember your rules of logarithms, right? I can bring this n power down here, and I can take natural log on both sides. You can take common log too if you want, but I prefer to take natural log because my math teacher in high school, Dr. Ang Lei Chang, just had a preference for using natural log and told all of us to use natural log if we ever have to take some kind of logarithm on both sides. Technically, you can take logarithm to whatever donkey number you want, but let's just use ln. You understand where this is going, right? Yeah. I hope you do. This is just simple math that you learn in Sec 3, I think. So I will divide across like this. You understand how we bring this power n down here and then we take the ln, right? Yes, okay. I hope you understand. If you key in your calculator, which I'm not going to do, you will get 9.264. So, after how many complete years? So therefore, number of complete years, they want complete year. So 9.264 is not a complete year. The first time this will happen at the end of a complete year will be after the 10th year. So number of complete years is equals to 10. Can? Next, part B, the woman decides that to assist her in her everyday expenses, she will withdraw the interest as soon as it has been added. Okay, let this be a progression, right? Let's say I have U1, U2, U3. So at the beginning of the year, I have Y. They're on the same plan, right? Yeah, they're on the same plan. The account will add 5%. So okay, let U1 be the amount at the end of the years. So U1 is 1.05x. Okay? U2 is going to be, she will withdraw the interest as soon as it has been added. Oh, no. Then this is a lot simpler. Because she will have 1.05 Y. She invests Y. And then she will withdraw the interest. Okay? And then U2 is just going to be repeating this process. And then she will withdraw the interest by withdrawing 0.05 of this entire thing. So this is going to be, no, I can generalize it to n already. So basically, show that at the end of n years. Oh, okay, so the total at the end of n years is going to be, I can factorize out 0.05y. This is going to be 1 year, yeah, plus 2 years, plus 3 years, plus all the way to the nth year. Gets? Okay. And then, because, right, this is 1.05 times 1.05. This is 1.05 squared. This is 1.05 times minus 0.05. Then over here, again, I have a 1.05 times minus 0.05. Then over here, I have a 0.05 times 0.05 will become 0.05 squared. So the two ones in the middle will cancel. The only thing I'm concerned about is the 1.05 squared here and the 0.05 squared here. Gets? Yeah, that's how I can factorize out the 0.05y. Then the number of so-called cycles of this will just be the same as the number of years. So that's why it's just one. So the total number of cycles at the end of n years is just 1 plus 2 plus 3 plus 4 plus all the way to plus n. So once again, I show you how to evaluate this kind of thing. Don't be stupid. But in this case, it's in terms of n, right? So what is this thing? This thing, can you see, people, this thing is just an arithmetic progression. So the sum of an arithmetic progression is going to be n over 2 a plus n minus 1d. So a plus n minus 1d, which is to say like that. And that simplifies to what they want to see, which is 1 over 40 n plus 1 y. Quite easily done. Okay, so yeah, hope you guys have enjoyed this. I don't know why I'm so tired at 8:19 p.m. But anyway, I'm gonna film another video after this. You can watch the next video after this if you want, the econs one. And yeah, let's see how things go as the night progresses. But anyway, hope you learned something and see ya. Bye bye.